Namaste. Welcome back to our channel, Qubit Educational Services. I'm Pranesh, the founder of the channel and an IISc Bangalore alumnus. In this video, we are going to solve the mathematics section from IISER Aptitude Test 2023. Let's begin with our first question. Let f be a function from the set of real numbers to open interval 0 to infinity. Let it be a continuous decreasing function. Suppose f of 0, f of 1, f of 2 up to f of 10 are in a geometric progression with common ratio 1 upon 5. In which of the following intervals does the value of the integral 0 to 10 f of x dx lie? And we have got four options: 0 to 2 into f of 0, 4 into f of 0, 6 into f of 0, 8 into f of 0, 10 into f of 0, 12 into f of 0, 14 into f of 0. Okay, now it's pretty simple actually. What we have to make use of is the fact that these numbers f of 0, f of 1 up to f of 10 are in geometric progression with common ratio 1 upon 5, and secondly, the range of the function, okay, the range of the function is a subset of the set of positive real numbers. Okay, 0 is not part of this, it is open interval. So what we can say is let f of x be, okay, let f of x be f of 0 into 1 upon 5 raised to x. Right, now when we do this, we are meeting the requirement that f of 0, f of 1, f of 2 up to f of 10 are in geometric progression with common ratio 1 upon 5, and secondly, because this common ratio is less than 1 but positive, the function is also a decreasing function. Okay, so now our job is to basically find out the integral of this function here from 0 to 10, this integral here. Okay, and what I can do is I can write f of 0 outside because it has no role to play in deciding the value, 1 upon 5 raised to x dx. Okay, now let's integrate this. Integral of a raised to x is a raised to x upon log a. Now it's log of 1 upon 5, which can be written as negative ln 5. Okay, now let's not forget that we need to substitute the limits as well here, 0 to 10. Okay, now last step, f of 0 here. Now look, let me write this as 1 upon ln 5. Okay, and because of this negative sign, I can first substitute x as 0, that will give me 1, and then I can substitute x as 10. Usually we do it the other way, upper limit and then lower limit, but because of this negative sign which already is present here, we can flip that sequence. Okay, so it will be 1 upon 5 raised to 10. Okay, 1 upon 5 raised to 10. Now calculators are allowed, so you can get the value of this expression on calculator. Let's do it here. Okay, let's do it here. Fraction 1 upon ln 5, 1 upon ln 5 into bracket 1 minus fraction again 1 upon 5 raised to 10, bracket closed. Now the value of this expression is 0.621. Okay, the value of this expression is 0.621. So basically the integral's value is this into f of 0. Okay, this into f of 0, so we need to pick that one. 0.621, so it's less than 1, so it's option A. Now this might happen for all the cases that the option is A, but in the exam they will shuffle the options, so it will not always be option A. Okay, this is the official PDF which is on their website, so every question will have option A, but don't be surprised by that. Okay, they're going to shuffle that particular options. Okay, next question, question 2. Let M be a 3 by 3 matrix with real entries such that the set of vectors x1, x2, x3 such that m into x1, x2, x3 is equal to 0, 0, 0 is equal to the set of the vectors x1, x2, x3 such that x1 plus x2 is equal to 0 and it is also equal to x2 plus x3. So we are given two sets. Both these sets contain 3 by 1 vectors or matrices, 3 by 1 matrices x1, x2, x3, and they are saying that these two sets are equal. Okay, these two sets are equal, and they are asking us to find the value of the determinant of M. Okay, now this is actually a problem, a standard problem in linear algebra. A standard problem in linear algebra, and well, one of the standard problems, the other one being the eigenvalue problem. Okay, so in this what we are given is, we are given a system of linear equations represented in the matrix form as Ax equal to B. Okay, and our objective is to decide the nature of the solutions of this. Okay, only three possibilities exist. Okay, first is unique solution, second possibility is no solution, and third possibility is infinitely many solutions. I'm not saying infinite solutions, I'm saying infinitely many solutions. Okay, and any system you take, it will belong to, well, not at least any one of these three categories, and these three categories are exclusive. So a system having unique solution cannot have infinitely many solutions, and well, also applies to other any two pairs. Okay, now when we have Ax equal to a null matrix, okay, Ax equal to a null matrix like we have here, such a system of linear equations is referred to as homogeneous. Okay, homogeneous. Now for homogeneous system of linear equations, the possibility of no solutions does not exist, because if x is 0, this vector is a null vector, then it will automatically satisfy the matrix equation no matter what A you take. And in this case we have got that particular system, right? M into x1, x2, x3 equal to 0, 0, 0. So if I take x1, x2, x3 all to be zeros, then obviously I'm going to get that particular solution, correct? So now the question is, for homogeneous system of linear equations, only two possibilities remain. Okay, only two possibilities remain. Which two possibilities remain? Either it is a unique solution, okay, either it has a unique solution or it has infinitely many solutions, right? Only two possibilities are there, unique or infinitely many. The no solution possibility does not exist. Got it? Now let's come to the system. We know that when our system has equal number of unknowns and equations, matrix A is a square matrix, right? And in this case it's M. M is 3 by 3, it's a square matrix, which means its inverse is going to exist. So for unique solution, A inverse, let me say A inverse exists, right? And then we can multiply by inverse and get it. And for infinitely many solutions, we say A inverse does not exist, obviously, right? Okay, now because they are saying that these two sets are equal, let's try to analyze the second set here. Okay, let's try to analyze the second set here, which says x1 plus x2 equal to 0. So I can write x1 as negative x2, and it also says that x2 plus x3 is equal to 0, which means I can write x3 as negative x2. Okay, x3 as negative x2, and I can now say that this is actually x2 into negative 1, 1, negative. Now this tells us something. What does it tell us? It tells us that when x2 is 0, we get trivial solution. Okay, trivial solution means the solution corresponding to U0, 0, 0 case. Okay, that is 0, 0, 0. But when x2 is non-zero, we get non-trivial solutions. Now solutions is important because by that we are saying take any x2, we will get one solution. So if I take x2 as 3, our solution will be negative 3, 3, negative 3. If I take x2 as negative 5, our solution would be 5, negative 5, 5. Okay, so it then falls into which category? It falls under the category of infinitely many solutions. Infinitely many solutions, and therefore the determinant of the matrix should be equal to 0. It should be a singular matrix, which means the correct option is A. Okay, again I'm telling you all these questions have option A as their right options, but it's only because, well, it's for the PDF sake, okay, which is available on the website. In the actual exam they will shuffle the options. Okay. Question 2, option A. Question 3. What is the locus of the center of circles passing through origin with fixed radius? Circle, hyperbola, parabola, line. Simple. What we have to do is we have to first start with the general form of equation of circle, which is x squared plus y squared plus 2gx plus 2fy plus c equal to 0. Now they are saying the circle passes through origin, so let's delete c. They are saying radius is fixed. Now if radius is fixed, what is the formula for radius of the circle? Radius of the circle is root of g squared plus f squared. Minus c is there, but c is 0. Okay. Now if radius is fixed, okay, let's call it a. What are we getting if we square it? G squared plus f squared equal to a squared. Now what does that represent? That represents a circle centered at origin. Centered at origin and radius a. Because this resembles the form x squared plus y squared equal to a squared. Correct? So it is a circle, option A. So here is a graphical verification of what we have just now proved. Okay, this is the circle that is variable x squared plus y squared plus 2gx plus 2fy plus c equal to 0, but I've deliberately not considered f separately. Instead I've written it as root of a squared minus g squared, right? Because that's what we have got here. If a squared is equal to g squared plus f squared, then obviously f would be root of a squared minus g squared. Okay. Now what I have done is I have kept a varying. Okay, I have kept a varying, and as you can see, our circle passes through origin, the red circle. Okay, the red circle passes through origin all the time, no matter what happens to the value of, and also no matter what happens to value of g. Okay, it always passes through the center. Now what interesting thing we would like to see is the green point. The green point here is the center of the red circle. Let me hide this one for a moment. Okay, this is the circle. So if I change it, if I change a, then you can see that that is the point. Okay, and if I change g, even then the green point moves with the red circle, that is the center. Now the result that we have got is actually the fact that the green dot lies on the circle whose center is at origin, and this is the case. That's indeed true. Let me hide this one now, and let me change a. It still is on that particular circle. Okay, and if I let g vary, you can see that this point is still on the circle. Let me also get this in action now. So we get that circle variable passing through origin, fixed radius a, but the center of it always lies on that semicircle at the bottom. Okay, so we have graphically verified our solution. Question 4. Let alpha be a real number. What is the total number of distinct points of intersection between the parabola y is equal to x squared plus 4x sine alpha plus 6 and the pair of lines y squared equal to 1, 0, 1, 2, 4. Acha. Now there are a few things here which we must know to solve this particular problem. One among them is the fact that because alpha is a real number, sine alpha always lies between -1 and +1. Okay. Secondly, the first term in this parabola, okay, the first term in this parabola is what? It is x squared. Now whenever the coefficient of x squared is positive, we know that the parabola is like u in this direction. Had it been negative, it would have been like this. Okay, fine. The third thing that we should know is the individual equations represented by this pair of straight lines, y squared equal to 1. Okay, now when y squared is equal to 1, we write it as y squared minus 1 equal to 0, and then we factorize it into y plus 1 into y minus 1 equal to 0, which gives us two lines, y plus 1 equal to 0 and y minus 1 equal to 0, which are basically y equal to minus 1 and y equal to plus 1. Okay, so these are two parallel horizontal lines, we know that. Okay, two parallel horizontal lines, y equal to 1 and y equal to minus 1. This is our x-axis. Okay, this is our x-axis. Now look, how many points of intersection can this parabola possibly have? Okay, it could either be like this, or it could be like this 2, or it could also be like this, where 4 points of intersection are there, or maybe something like this. Okay, maybe something like that. But how to handle that? See, what we can do is we can go for the largest and the smallest values of sine alpha. Okay, and we can find the minimum of this parabola or the quadratic function, and then we can look after it. Okay, so let's now go for this. Okay, let's now go for this, and let's consider the least value of sine alpha. So sine alpha min is minus 1. So we will have y equal to x squared minus 4x plus 6. Let's take the derivative. It is 2x minus 4 equated to 0. We will get x equal to 2, and then we can find out y there. Six plus 4, 10, 10 minus 8, y is 2. Okay, now we know it's y min actually. Okay, we know it is actually y min. Now look here, this y min is somewhere here. And because this x squared is positive, the whole shape of the curve is going to be like this. Okay, the whole shape of the curve is going to be like this. So can it have any point of intersection whatsoever? No. Okay, it cannot. So the correct option is A, 0. The option is not important. The number of points is important. Okay. Now you might ask, what will happen if we take the other extreme, if we go for the other extreme? That is, if we go for sine alpha max equal to 1. So here y will be x squared plus 4x plus 6. Let's take the derivative, which will be 2x plus 4 equated to 0. We will get x as minus 2. Put it here. What will be y min in this case? 4 minus 8 plus 6, 6 plus 4, 10, 10 minus 8, so again 2. Okay, so that is definitely not going to change for both minus 1 and plus 1, and hence the graph is never going to intersect the pair of straight lines, hence the correct option is A. Okay, now I'm also going to show you how to do this graphically. So look here. Now instead of taking sine alpha, I'm taking A as my parameter. Okay, I'm taking A as my parameter, and I know that sine alpha ranges from minus 1 to 1, so I've limited the range of A in between minus 1 and 1. Now I'm going to start at the animation. Currently we are at negative 1. Okay, we are currently at negative 1, and as we know, it's 2, 2. It's 2, 2. Well, although I said y min equal to 2 here, the point should have been somewhere here, but because we have not yet specified where the origin is, we are saved. Okay, this is not the origin. Okay, so this is y min, so this is the x equal to 2, right? Okay, x equal to 2. Okay, that is this one. X equal to 2. Okay, x equal to 2. This line. Now let us begin the animation and see where the curve goes. It actually goes up. It actually goes up. It actually goes up, and then when it goes to a's value as 1, it now comes to minus 2, 2. And we've got minus 2 here. We have got it minus 2 here. Where have we got it? We have got minus 2 here. Okay, on this side we got minus 2, and on this side we had got plus 2. Okay? Which basically means that the graph of x squared plus 4x sine alpha plus 6 never meets the upper line also. Forget about the lower line, and therefore no points of intersection of the parabola with the pair of lines. Question 5, very simple question. Let L be a straight line passing through the origin, and it makes angle alpha, beta and gamma with positive x, y and z axes respectively. What is the value of cos 2 alpha plus cos 2 beta plus cos 2 gamma? This is actually a standard NCERT textbook problem converted to MCQ, and it has also been repeated many times in many state level engineering entrance examinations. Okay, we can solve this problem in two ways. I'm going to tell you one way, which is actually simpler. Let's call it special case approach. Okay, because they have not specified what line it is, and additionally only one of the 4 options is going to be right, we can pick any line of our convenience. So let's take x-axis itself. Okay, let's take x-axis itself as L. Now what is the angle made by x-axis with itself? 0. What is the angle made by x-axis with y-axis? Positive pi by 2. And what is the angle made by x-axis with z-axis? Gamma, also positive 90. So what is this expression? Cos 2 into 0, cos 0 is 1. 2 beta, beta is pi by 2, so 2 beta will be pi, cos pi minus 1. And then cos, again it will be minus 1 because it is cos 2 gamma. Gamma is pi by 2, cos gamma is, cos 2 gamma will be cos pi, which is minus 1, so the correct answer is minus 1. Okay. Now the other approach is to make use of this fact. Sum of squares of direction cosines is 1. Okay, cos squared beta plus cos squared alpha plus cos squared gamma equals 1. And we have to use the double angle formula. 1 plus cos 2 alpha is equal to 2 cos squared alpha. So I'll leave this part to you. You can easily prove this using the identity that I have written here and the trigonometry formula that I have written here. Okay, so use these two as homework to get the correct answer as minus 1. Question 6, based on counting principles, which says what is the total number of distinct divisors of 2 raised to 9 into 3 raised to 90. Okay, now look here. This problem is obviously trick based problem, but if you understand the logic, the way it works, even if you don't know the formula or the trick, you can still very easily solve the problem. Okay, look here. Firstly, note that both 2 and 3 are primes. Okay, so no matter whichever divisor you take of this number, okay, whichever divisor you take of this number, it would either be a pure power of 2 or it would be a pure power of 3. Okay, or it would be 1 where both the powers of 2 and 3 will be 0, or it would be a combination like this, 2 raised to x into 3 raised to y. Got it? Which means, see now, when it comes to pure power of 2, I know that the power of 3 will be 0. When it comes to pure power of 3, I know it will be something like this. And when it is 1, I know it is 2 raised to 0 into 3 raised to 0. Which means, if I want to count the total number of distinct divisors, I can convert it to a counting problem. How can I convert it into a counting problem? I will say My factor will obviously be of this form, 2 raised to x into 3 raised to y. I'll say x can be either 0 or 1 or 2, or how far should we go? We should go till 9. So x can have 10 values. And I'm saying and, so I must use multiplication principle there. I must use multiplication principle. Similarly, what about y? The largest power of 3 is 19. So I can say y can either be 0 or 1 or 2 or up to how far should we go, or 19. So how many values, how many distinct values can y have? 20 values. Okay, so 10 values of x, 20 values of y. X can have any one of those 10 values, y can have any one of those 20 values. So the total number, if we get by multiplication principle of counting, by multiplication principle, the total number would be 10 into 20 equal to 200. Now it's not the case that only two divisors, two prime divisors our number can have. Let's say, for example, if you take a number like this, let's say 2 raised to a, 3 raised to b, 5 raised to c, 7 raised to d. Suppose you take this number and you ask me the question, how many distinct factors does this number have? I'll say it would be a plus 1, b plus 1, c plus 1 into d plus 1. Now why are we adding 1 to these? We're adding 1 because we know that if a max is, let's say, 10, the number of values of a will be 11 from 0 to 10, because we want 1 also to be the factor. Okay? So the correct answer is A. Question 7 from statistics. Suppose the mean and the standard deviation of the data x1, x2 up to x9, 9 values, are mu and sigma not equal to 0 respectively. After including one more data value x10, the mean of the data remains mu. What is the standard deviation of the data x1, x2, x3 up to x10? So basically we have 9 values initially whose mean is mu, standard deviation is sigma. We're adding one more value but the mean remains the same. What do you understand from that? From that you understand that x10 is actually equal to mu. Right, x10 is equal to mu. How? Look here. Mu is actually sum of all values as I goes from 1 to 9 upon 9. Okay, so this sum is actually 9 mu, right? Therefore summation xi as I goes from 1 to 9 is 9 times mu. Okay, and that's why the mean is mu. So you are adding x10 to this addition and then again dividing by 10 and you are still getting mu. So if you solve this equation you will get x10 to be equal to. Got it? Fine. So we have now successfully proved that the number that is being added is actually mu. They have not told that in the problem, but we are supposed to find that out first, that the number that we are adding, one more data value, that is mu itself. Okay, now let's go to the definition of variance, because we know that standard deviation is root of that. So let's say sigma squared, what is it? Summation xi minus mu the whole squared upon total number of values. In this case it is 9. Okay, in this case it is 9. Now let's go for sigma nu. Because the mean remains unchanged, now let me write it like this. Look, there are now 10 values, but let me write it like this only. Okay, let me write it like this, and then I need to consider x10 minus mu the bracket squared. Correct, I need to consider x10 minus mu bracket squared, and I need to divide this by 10 because now we have got 10 values and not 9. But now if you see because x10 is equal to mu, this term becomes 0. This term becomes 0. So what do we have now? We therefore have 9 sigma squared from this first case equal to 10 into, sorry, should have squared it, sigma nu squared. Why? Because both of them will be equal to what? Both of them will be equal to this particular expression, right? Both of them will be equal to this particular expression, and therefore sigma nu squared is equal to 9 sigma squared by 10. Because standard deviation is the positive root of variance, okay, it will be 3 sigma by root 10. Correct option is A. Okay, what were the key points in this sum? The key points in this sum were the new term that we were adding is mu itself, was the mean itself, because the mean of the new data was not different from that of old data. Second important thing was the standard deviations definition or variances definition. Sometimes we use the shortcut to find the variance, especially in probability distributions, random variables, but here we are using the definition of variance and not the shortcut, right? Alright, that's question 7. Question 8 from probability. Consider 3 biased coins. Let the probability of getting head be 1 upon 3 and the probability of getting tail be 2 by 3 in each of the coins. So they are not fair. Consider the experiment of tossing the 3 coins one by one and the following events. E, at least 2 heads show up, and F, first coin shows tail. What is the conditional probability of E given that F has already occurred? So we need to basically find P of E given F. Okay, we need to find the probability of E given F. How to find it? We can use the conditional probability theorem. Okay, so it basically says probability of E intersection F, okay, upon probability of F. Now we have to be a bit more careful here while assigning the probabilities to the events E and F. Okay, look, there are 3 coins, okay, and we know that none of the 8 outcomes is forbidden, right? What are the 3 outcomes that we get if we toss 3 coins? We know that, so let's make a table of that quickly. H, 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 T, 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 right? Then H, H, T, T, H, H, T, T, then H, T, H, T, H, T, H, T. Okay, now to make things easier, I'm going to make a separate table for event E and event F. Okay, let's first consider event E. At least 2 heads show up. At least 2 heads. Okay, so first, second, third, fifth, that's it. Okay, at least 2 means 2 or more than 2. 3, 2, 2, 2. Okay, so what is the do we need probability of E separately? We don't. Okay, so let's just skip that. Okay, now let's go to probability of okay, so E is done. E is done. The outcomes that belong to E are done. Now let's go to F. Okay, what is F? First coin shows tail. First coin shows tail. So for F we have got 1, 2, 3 and 4. Okay, now because these basically are sample events, we can add their probabilities to calculate the probability of F. Okay, so what is the probability of F? Now please pay attention, this part is important. Look here. Firstly, we have got T, H, H. All these events are independent, like getting a T on the first, getting head on second, right? What is T? H is 1 upon 3. Let me write it here. H is probability 1 upon 3, tails probability is 2 by 3. So we can just multiply. Okay, probability of F. T, H, H. T once, H twice. So it will be 2 by 3 into 1 upon 3 squared, right? H, H plus T, H, T. So tail twice, 2 by 3 squared, 1 upon 3 as it is. Lastly, we have got again tail twice, right? Tail twice. Tail is 2 by 3, so into 2. And then finally all 3 tails, so 2 by 3 cubed. 2 by 3 cubed. Got it? Now let's simplify this. All of them will have the same denominator, that is 27. It's 2. 2 squared is 4. 4 into 2, 8. And then again this is 8, right? 2 cubed is 8. 8 plus 8, 16. 16 plus 2, 18. So this will be 18 by 27. Okay, 18 by 27. Now let's go for the probability of, or 2 by 3. Okay, sorry, 2 by 3. Now let's go for the probability of E intersection F. Okay, now how many elements are common between E and F when we can say that both of them have taken place? It's this one, THH. THH. So what is the probability of this particular event happening? THH. T is 2 by 3. T is 2 by 3, head is 1 upon 3, so it will be 2 by 3 into HH, so 1 upon 3 squared. So how much would this be equal to? How much would this be equal to? This will be equal to 2 by 27. 2 by 27. Okay, so we've got the formula. We will basically substitute the values now. Okay, we will substitute the values now. This will be equal to 2 by 27, that is E intersection F, the numerator, upon P of F, that's 2 by 3. 2 will get cancelled, 3 will get in the numerator, 3 by 27, 1 upon 9. 1 upon 9 here, okay, option 9. Okay, I would say a bit trickier problem, but not too hard, slightly above JEE main or even JEE main level, I think we can say that. The different thing about this is they're saying that the coins are not unbiased, they're biased. Okay, the coins are unbiased, but luckily for us the number of such tosses was not too large, only 3 coins were there, so 8, so we could basically prepare a table and get rid of the problem, or I mean basically solve the problem. Now it would be an interesting case to see what if they're giving n biased coins. If you want, you can try this general case, take n biased coins and develop an expression for probability of F and probability of A intersection F, divide and get the function. Okay, you can try that and comment your answer below. Alright, question number 8. Question 9 on differential equations, pretty simple one. Which of the following differential equations has y equal to e raised to x as one of its particular solutions? Particular solutions means solutions having no arbitrary constants. Okay, and we've got 4 options. Let's read them carefully. Y d2y by dx squared minus e raised to x dy by dx plus y squared equal to e raised to 2x. Y d2y by dx squared plus e raised to x dy by dx plus y squared equal to e raised to 2x. Y d2y by dx squared minus e raised to x dy by dx plus y squared equal to e raised to x. Y d2y by dx squared plus e raised to x dy by dx plus y squared equal to e raised to x. Observe that in all 4 of them we've got y squared here. So what is y squared? E raised to 2x. Also observe that in all of them we've got e raised to x dy by dx. Dy by dx is again e raised to x, so e raised to x into e raised to x will be e raised to 2x, right? And now we have got y d2y by dx squared. What would this be? This would be e raised to x into second derivative will again be e raised to x. Okay, now if all of these things had plus signs, all the terms, then we would have basically got 3 e raised to 2x on the right side, and that's not the case. Other thing, even if some of these terms have had minus sign, we would have still got e raised to 2x everywhere. Hope you realize that. E raised to 2x. So clearly options C and D are not right. Not right. If all of 3 had been positive, then we would have basically got 3 e raised to 2x, right? Not that. So it is option A. Why? Let's check that again. Y d2y by dx squared, so e raised to 2x. Minus e raised to x dy by dx, so minus e raised to 2x plus y squared plus e raised to 2x. That matches with the right hand side, so correct option is A. Okay, see, in the exam you will not know that it's option A. Because this is the official PDF, every option is A. In the exam they will shuffle. So you have to notice the pattern in the options, if any, and accordingly you have to solve the problem. Question 10 on applications of definite integration. What is the area of the region xy such that 0 less than or equal to y less than or equal to x e to the power x squared, 0 less than or equal to x less than or equal to 1? And we have got 4 options. It's a pretty simple problem, I would say. Look, what they are giving is Okay, so this is y equal to 0. Okay, and then this is x equal to 0, y-axis, and suppose this is x equal to 1. Okay, observe that both e raised to x squared and x are increasing functions, right? So, and at x equal to 0, the value of the function is 0. Which function? X e to the power x squared at x equal to 0 is 0. So the function is going to be an increasing function like this. Okay, it is going to be an increasing function like this, and it will eventually intersect this vertical line x equal to 1 somewhere. Okay, to be specific, that point would be 1 comma e. This particular point would be 1 comma e. Our job is to find this green area here, and I think now everybody will be able to solve this problem. It's pretty simple, right? 0 to 1, x e raised to x squared dx, substitute x squared as t, 2x dx would be dt, x dx would be dt by 2. Will there be any change in the limits? Let's see. We have got x as 0, 1, t is x squared, 0 squared 0, 1 squared 1, so no change in the limits. So area is equal to integral, t's limits are now from 0 to 1, x is, x dx is dt by 2, okay, dt by 2, e raised to x squared will be e raised to t, integral of e raised to t is e raised to t, upper limit 1, lower limit 0, e raised to 0, 1, so e minus 1 upon 2 square units. Area, it's a physical quantity, so should write this. Okay, so again option A. Now let's verify this graphically. Okay, let's verify this graphically, and let's also take into consideration the other area. Okay, look here. So I've already plotted the function for you, x e raised to x squared between 0 to 1. This is the graph. Okay, and if you plot the area, if you find the integral on Desmos, it turns out to be 0.8591 approximately, and if you go for 1 upon 2 into e minus 1, it shows you the same thing. Okay, now look, suppose I plot e raised to x, or e raised to t for that matter, between 0 and 1. Okay, between 0 and 1, we get to know some interesting results now. Look here, suppose I go for integral from 0 to 1 e raised to x, or e raised to t dt in our case, but the variable of integration is a dummy variable. Now, and if you divide this by 2, you'll again get the same answer there. What does it mean? It means something interesting. Okay, means something interesting. What does it mean? It basically means the following: the green area that we have computed just now, okay, the green area that we have computed just now, and let's say this chocolate area, they both are same. So this kind of acts as the bisector of areas. Okay, this area is also e minus 1 upon 2, this area is also e minus 1 upon 2. Although not asked, who knows, they can ask you a problem like this year or even in subsequent exams. Okay, you can say that this is bisector of area curve, right? Bisector of area curve, because it bisects the area between the upper curve x-axis, two vertical lines. Got it? That was question number 10. Question 11 from linear programming problems, LPP. Consider the objective function z equal to x minus y subject to constraints x plus 2y less than or equal to 10, x plus y greater than or equal to 2, x greater than or equal to 0, y greater than or equal to 0. What is the minimum value of z subject to the above constraints? I have deliberately not shown the options. Let's try to find that out. Okay? It's typical LPP. Let's first go for x plus y greater than or equal to 2, convert it to equation. Take x0, you will get y as 2, take y0, you will get x as 2, and because it is x plus y greater than 2, it is the non-origin side. of the line, right? Now let's come to this, x plus 2y less than or equal to 10. Okay, convert it to equation so that we can draw a line, x0 y5 y0 x 10, and because if you substitute the coordinates of origin here, 0 plus 2 into 0 0, which is less than 10, we get origin side for this. The non-negativity constants, well, basically they ensure that our feasible region is in the first quadrant. Okay, okay, so let's draw the region now. Okay, let's draw the region. You have to do this approximately because ruled scales are not allowed in the exam, right? Let's first go for 0 to 2 0. This is 2 0. This is 0 2. Let's draw the line joining them. Okay, and this is going to be the non-origin side. Which equation is that? X plus y greater than or equal to 2. So in this case it will be this. Okay, next 0 5 10 0 0 5 0 5 is this, 10 0 is this. Go for it. These lines will definitely not intersect in the first quadrant. They will intersect somewhere in the second. Of course we are not interested in locating that. Which equation is this? X plus 2y equal to 10, right? X plus 2y equal to 10. And what is the feasible region now? The feasible region is this green one. Okay, the feasible region is the green. So you've got 4 vertices, 0 to 2 0. This is 0 comma 5 and this is 10 comma 0. Now, I mean, the trap for which you can fall is this. Look, usually when we take the objective function in our problems, numerical or word problems, formulation and then solving, A, B are positive usually. But in this case, A is positive and B is negative. So we have to be a bit more careful here. We want Z min, right? So we would like X to be as small as possible and Y to be as large as possible, right? X minus Y. Now by convex polygon theorem, the vertices will act as the points, corner points. Okay? So I start with 0, 2. Let me write the value of the objective function in green color now. X minus Y minus 2 minus 5, 10 and 2. So what is the correct option or correct answer? Minus 5. Minus 5. This is Z min. And what is Z max? Z max is 10. Okay? Yeah, so whichever option corresponds to minus 5, that is going to be the right option to question number 11. Question 12. Let p of x be x squared plus bx plus c. Let it be a quadratic polynomial with real coefficients p and c. Suppose p of 1 is 5, p of minus 1 is 3. What is the product of the roots of p of x equal to 0? 3 minus 1, 2, 1. It's a fairly simple problem. Now, we know that sum of the roots of any quadratic equation is negative of the coefficient of x upon coefficient of x squared, so that's negative b. And the product of the roots is the constant term upon coefficient of x squared, so that's c. So we basically need value of c. Just put them here. Okay, use p of 1 equal to 5, so 5 will be equal to 1 plus b plus c. P of minus 1 is 3. 3 is equal to 1 minus b plus c. Okay, 5 plus 3, 8, 2, 0 b plus 2c. 4 is equal to dividing by 2, so 1 plus c, c equals 3. Option A. Okay, fairly simple problem. Question number 13. Let f from open interval minus 1 to 2 to r be a differentiable function such that f dash of x is 2 upon x squared minus 5 and f of 0 be equal to 0, then in which of the following intervals does f of 1 lie? Okay, in which of the following intervals does f of 1 lie? Now one thing we must take a note of is that f dash of x is undefined. Okay, f dash of x is undefined at x equal to plus or minus root 5, because that's where the denominator becomes 0. Now what is the domain of f? Domain of f is open interval -1 to 2, and none of these values plus or minus root 5, none of them belongs to -1 to 2, so we are okay with that. Usually those things are ignored, but there could be a trick question which basically will require you to consider that in your integration process. Okay, so we have f dash of x, f of 0 is also given, so we can first integrate f of x, integrate f dash of x to get f of x. Integral f dash of x dx. Let's now write it in the form that we want. 1 upon x squared minus root of 5 the whole squared dx. So what is the formula now? The formula is 1 upon 2a ln mod x minus a upon x plus a. Remember, this is an indefinite integral, so let's add c there. And f of 0 is 0. F of 0 is 0 implies 1 upon root 5 ln 0 minus root 5 upon 0 plus root 5, so that is negative root 5 upon positive root 5, negative 1, ln negative 1. But ln mod negative 1 is basically ln 1, which is 0, so c is 0, right? C is 0, and therefore we can directly write f of x as 1 by root 5 ln mod x minus root 5 upon x plus root 5. Okay, x plus root 5 in the denominator. F of 1 is what we want. F of 1 by root 5 ln mod 1 minus root 5 upon 1 plus root 5. Use calculator because it is allowed. So 1 by root 5 into ln. Now instead of taking mod, let me write it as root 5 minus 1, and in the denominator it will be root 5 plus 1. Okay, now we know that this number is going to be less than 1, so its log would be negative 0.43. Now was that enough for the option selection? Yeah, it was actually enough, because the moment we notice that root 5, the numerator of this fraction is smaller than the denominator in magnitude also, this number would be negative, because natural log of any number less than 1 is negative. So the function's value would also be negative. So option A. Okay, option A. Second last question, question 14, based on functions and graphs. Let f of x be sine of 3x. X belongs to the closed interval 0 to pi by 2. Which of the following statements is true? Function is increasing on open interval pi by 4 to pi by 3 and decreasing on open interval pi by 3 to pi by 2. F is decreasing on pi by 4 to pi by 2. F is decreasing on pi by 4 to pi by 3 and increasing on pi by 3 to pi by 2. F is increasing on pi by 4 to pi by 2. I have deliberately shuffled the options so that it will not be option A all the time. Okay. Now one thing we must remember, and that is the graph of sin x is like this. Okay, the graph of sin x is like this, with 0, pi and 2 pi here. This is pi by 2 and this is 3 pi by 2. Okay, this is 3 pi by 2. Now when it comes to graph of sine of 3x, the graph actually shrinks. Okay, so the period of sine 3x is not 2 pi into 3, but it is 2 pi by 3. Okay, we have studied this already in wave motion. Okay, we have already studied this in wave motion, but here now I am explaining it again. Okay, now pay attention how the graph of sine 3x is going to behave. Okay, how the graph of sine of 3x is going to behave. It basically has the same shape. Okay, if it basically has the same shape, okay, and its range is also equal to -1 to 1. Okay, its range is also equal to -1 to 1. So the number here is -1, the number here is +1. The only change that happens is everything gets divided by 3. So this is 2 pi by 3. I'm only showing one cycle. This will be okay, so how much will this be now? 3 pi by 6. So this will be pi by 2. This is pi, so this will be pi by 3, and this will be pi by 6. Okay, just divide every number here, pi by 2, pi 3, pi by 2, 2 pi by 3. Okay, your job will be done. Okay, had it been sine 4x, we would have divided by 4. Okay, great. Now let's go for option A. F of x is increasing on pi by 4 to pi by 3. Now pi by 4 is 45 degrees. Okay, pi by 4 is somewhere here. Is it increasing? No, it's decreasing, so this option is gone. Let's come to this now. F is decreasing on pi by 4 to pi by 3. Yes, it is true. This part is true. And increasing on pi by 3 to pi by 2. Now, what is happening to the graph between pi by 3 and pi by 2? It continues to decrease. So is this option right? It's not right. Okay, it's not right because it is decreasing there. Next option, f is decreasing on pi by 4 to pi by 2. Is it true? F is decreasing on, let me change a color. Okay, is it true that f is decreasing on pi by 4 to pi by 2? Pi by 4 is here, pi by 2 is here. So answer is yes, it is decreasing and not increasing. So wherever f is decreasing on open interval pi by 4 to pi by 2 is there, we should mark that particular option. Okay, now let's verify this graphically. Let's verify this graphically whether it indeed decreases in the interval pi by 4 to pi by 2. Okay, so I've already plotted the graph for you. Let's now go for pi by 4 less than or equal to x less than or equal to pi by 2. So just look at the blue patch. Just look at the blue patch. Okay, just look at the blue patch. In the blue patch, we'll find that the graph from pi by 4 to pi by 2, these values are excluded. Okay, pi by 4 we may have included that, but definitely not pi by 2, because it then it would lose the property of strictly decreasing. But nonetheless, in that interval, the function is decreasing. Okay, let me paste the graph of this function here for our reference. Okay, pi by 4 to pi by 2, pi by 4 to pi by 2. Yes, let's now go to last question. Question 15. Which of the following functions is differentiable at x equal to 0? Mod of x raised to half, cos of mod x, sine of mod x. Now, we know that mod x is definitely not differentiable at 0, right? Because it has a corner there. To look for the differentiability of the other three functions, let us first start with sine of mod x. Okay, let us first start with sine of mod x, and let's note the definitions of these. It is equal to sine of x when x is positive, and it is equal to negative x when x is negative, because mod of x is negative. Okay, now if we take the derivatives here, it would be cos x here, and sine of minus x's derivative will be cos of minus x into minus 1. Okay, now at 0, this value is 1, this value is how much? Minus 1. Are they same? Not same. So is sine of mod x right? It's not right. Okay, now let's go for cos of mod x. Let's go for cos of mod x. Okay, now it doesn't really matter now about cos of mod x, because cos x itself is an even function, but let's see. X positive, cos x. Okay, x positive cos x, x negative cos of minus x, but it is actually equal to cos x. Okay, it is actually equal to cos x when x is negative, right? Now let's take the derivative, minus sin x minus sin x. Let's substitute x equal to 0 because we want to investigate the differentiability of this at x equal to 0. Okay, at x equal to 0. So this 0 sin 0 0. So at x equal to 0, right hand derivative is 0, left hand derivative is also 0. So they are same. Therefore the correct function which is differentiable at 0 is cos of mod x. This option is right. Okay. Why is mod x's root not differentiable? Because even if you take the values of x which are positive, where mod x is equal to x, mod of x raised to 1 upon 2 is actually root x itself. And we know what its derivative is. It is 1 upon 2 root x. Okay, so basically this is not differentiable at 0 because you see what happens when x is 0, right? So there is no question of mod of that and then root being differentiable, right? Let's now check this graphically one by one. Okay. Okay, so we had started with sine of mod x, and you can see that clearly it basically behaves like mod x at 0, so clearly not differentiable there. Okay. Now let's go for cos of mod x. Cos of mod x. For cos it doesn't really matter because it's already an even function, so it is clearly differentiable. The smoothness is there. Okay, now let's go for mod x's square root or raised to 1 upon 2. Okay, yeah, that's the thing, right? It has a cusp there. We call this point a cusp. Okay, what do we call this? We call this point as a cusp. Okay, this point as cusp. Okay, which is a common tangent there. Two branches have a common tangent there. That's a cusp. Okay. Alright. So that completes IISER Aptitude Test 2023 Mathematics Solutions. We have launched Concepts Development Program, that is CDP, specifically for IISER Aptitude Test, NEST and other allied entrance examinations. We highly recommend you to join the CDP for an improved performance in IISER Aptitude Test and of course achieving your dream institute through IISER Aptitude Test and NEST. Thank you for watching. Please consider subscribing to our channel if you think our channel is helping you in your IIT preparation. Thank you. Thanks a lot. And all the best for your examinations.